Hi, this video is about understanding velocity versus time graphs. Let's start with an object at rest. So when an object is at rest, its position versus time graph could look like a flat line anywhere. So you could have a flat line here. Oh, that's not very flat. You get the idea. Or a flat line down here. It doesn't matter. It could be anywhere on the axis. But for a velocity time graph, it can only be in one place, and that is right here. Oh, my marker. It's hard to write at this angle. There we go. An object at rest must mean that the velocity has a value of exactly 0. So it can't be anything up here, which would be, more than 0, a 1, 2, 3, or so on. And it can't be anything down here either, because that would be more than 0 speed as well, just in the negative direction. So these are still speeds moving, but they're just moving in the opposite direction. So an object at rest is always going to be a speed of 0. For an object moving at a constant speed, a position versus time graph could look anything like a straight line. It could be a straight line moving up or a straight line moving down. In this case, I drew a straight line moving up. So the velocity is in the positive direction, which means it needs to be on the positive end of the graph and not the negative end. So any straight line over here will do. The velocity graph will look something like that. Now, if I drew a line going in the negative direction, I would draw this line, but the velocity would be negative instead. All right, let's look at some other examples. What if an object is speeding up? For a position versus time graph, an object speeding up means it starts out with a relatively low slope, not much, but then that slope gets steeper and steeper and steeper, causing a parabola type shape or just a shape that gets steeper. So to show what that, I left off my XNV over here. Oops, that's a physics boo-boo there. Allow me to fix that. Thank you. So speeding up means that the velocity starts off pretty close to 0, and then it moves away from 0. So in this case, the velocity is moving in the positive direction. The object is moving up in this case. So the velocity is going to start out moving a little up, but then it's going to get more and more and more up. So that might look something like this, where the velocity starts out a little bit in the positive, velocity, a little bit of magnitude, and then that magnitude is just going to grow and grow and grow and grow. So it'll look something like this, a straight line moving away from 0. Now, if I did this in the other direction, I flipped it, then it would be moving away from 0, but in the negative direction. For an object slowing down, let's say we start off with a steep slope moving in the negative direction, but that steep slope doesn't stay steep. Instead, it starts to level off a bit, and so it slows down in the process. So to show that as a velocity graph, in this case, we're moving in the negative direction. So we're going to start down here in the negative velocities, not the positive velocities. And we're going to start out with a pretty high velocity. That means we're going to be pretty far from 0. So if this is no speed, this is a little speed, this is a lot of speed, this is very, very fast. Let's start at the very high negative velocity down here. And we're starting off high, but we're getting slower and slower and slower. Eventually, it looks like we might even come to rest. So if that's the case, we'll end up back here at 0. So this would be slowing down. Well, now we don't want to keep going past this, because then that means we've crossed over 0 velocity and now we're speeding back up, but in the other direction. So we stop there. All right, let's do one more. What do these graphs mean here? We've kind of hinted at it now, but comparing these side by side is very instructive. Starting with this one. So we have this velocity versus time graph, but both of these are velocity. We start off in this one with a very fast velocity in the positive direction. We know it's fast because it's pretty far from zero. Zero is right here, no speed, so it's pretty fast. And it gets slower and slower and slower, steadily slowing down, and then at the end here, it remains at rest. This graph is different in some ways because now our velocity starts in the negative direction. So starts fast in the negative direction, but then it's moving towards zero velocity here. So it's getting slower and slower and slower until eventually it stops as well. So it steadily slows down and then remains at rest. Now, if you compare these two, you'll notice the only difference is that one started in the positive direction and the other one started in the negative direction, but they both end up slowing down and then coming to rest. So this is slowing down and this is slowing down. And the reason why it is like that is because you have to remember this line right here, this time axis, intersects with the velocity where the velocity is zero. So if you're approaching this axis, that means you're approaching zero velocity. Either side, either way you come at it, you're approaching zero velocity. That's what these graphs are so tricky for, is because it doesn't register in our brains like the position versus time graphs do. When we get closer and approach this axis, we're really getting slower. Both ways, you're getting slower because you're approaching zero velocity. So I think it'll make more sense if you do some practice yourself and try to quiz yourself on what different velocity time graphs mean. But that's all I've got for you in this video. So remember, everything you have is a gift.